Okay, let's talk about partial fraction decomposition. Partial fraction decomposition is applied to rational functions, so to functions q of x that can be written as a ratio of two polynomials, in this case p of x over r of x, where the degree of p of x, so the degree of the numerator, is strictly less than the degree of the denominator r of x. So once you have such a rational function, then we want to talk about the factored form of r of x and talk about several different cases. Depending on the factored form of the denominator, we will have to discuss several different cases. Okay, so first of all, when r of x is factored, it can have basically linear factors and irreducible quadratic factors in general. So in general, the factored of r of x will contain linear factors. If you recall, linear factors are of the form ax plus b, that's the most general form of a linear factor, and or irreducible quadratic factors which these irreducible quadratic factors are of the form ax squared plus bx plus c. And if you recall, this is irreducible, which would mean that basically this polynomial has only complex roots. Okay, these factors can be repeated factors. Or not, right? So in general, if you factor a polynomial, it probably will factor as a product of linear polynomials, linear factors, and irreducible quadratics. And some of these factors might be actually repeated, meaning that they have an exponent that is bigger than 1. Okay, now we're going to take each of these cases separately. So the first case that we're going to talk about is the case when the denominator r of x is a product, the product of non-repeated unique the product of unique linear factors. Okay, so in this case we start out with some rational function q of x that can be written as some p of x over a product of unique linear factors, so a1x plus b1 times a2x plus b2. Let's say there's n such unique linear factors. There are n such unique linear factors. Okay, so this is the first case. Now, what the partial fraction decomposition theory tells us is that basically there exists constants, real numbers, a1, a2, a sub n, such that the original rational function q of x, which was p of x over a1x plus b1, a2x plus b2, dot dot dot, a sub n x plus b sub n, can be written actually as the sum of the fractions a1 over a1x plus b1 plus a sum a2 over a2x plus b2 plus all this so on till the last, which is a sub n over a sub nx plus b sub n. Okay, so bottom line, partial fractions method takes a particular rational function, in this case one whose denominator is a product of unique linear factors, and basically this method will help us rewrite this original fraction as a sum of fractions whose denominators are simple linear polynomials. Okay, so for example, the idea is to take something like x, 2x plus 1, say, over x squared minus 3x minus 4, and try and rewrite this as a sum of fractions that have actually denominators that are of smaller degree than this. Okay, so basically let me just start out by factoring the denominator, and we end up with x minus 4 times x plus 1. Okay, so now let's try to use the partial fraction decomposition on this particular rational function. So the idea is the following. We want to find constants a and b such that a over x minus 4 plus some number b over x plus 1 will have the property that when I add these two fractions together, I end up with the fraction that I started out with, namely 2x plus 1 over the x minus 4 plus x plus 1. Okay, so what we're going to do in order for us to find this a and b, we are actually looking for these numbers by making common denominators. So the first fraction I'm going to multiply through by x plus 1. I get a times x plus 1 plus b times x minus 4. So the second fraction here I multiply through top and bottom by x minus 4, and we want a x plus a plus bx minus 4b divided by the x minus 4 times x plus 1. we want this fraction to equal the original fraction 2x plus 1 over x squared minus 3x minus 4. Okay, so let's keep going. So this actually, let's organize this. I have ax plus a plus bx minus 4b. I'm going to collect like terms. There's an ax plus a bx. And I'm going to deal with the coefficients. Since I cannot really add them up, I'm just going to factor out an x from both of those. So I end up with x times a plus b. And then I still am left with the a minus 4b. And I cannot do anything with those, so I'll just write them down. X minus 4 times x plus 1. Okay, so our goal is to find a and b such that basically a plus b times x plus a minus 4b over x plus 1 times x minus 4 is equal to the fraction we started out with, which is 2x plus 1 over x plus 1 times x minus 4. Okay, now this is the idea. Two fractions whose denominators are equal are going to be equal only if their numerators are equal. Okay, so a over b, so this is a side, a over b equals c over b if and only if a is equal to c. Okay, so in this case, so we are back now to the problem. If I take, basically I want a plus b x plus a minus 4b to actually equal 2x plus 1. Now there's another trick here. I have one polynomial on one side and I have another polynomial on the other side. Turns out that two polynomials are going to equal if the coefficients of the corresponding terms are equal. Okay, so that's what's basically going to help us figure this out. So the only way this side, the left side, is going to equal the right side is if the coefficient of x on the left is equal to the coefficient of x on the right. So in this case, we want a plus b to add up to 2. Then we also want the constant terms to equal individually. So a minus 4b should add up to 1. Okay, and now you see why we cover partial fraction decomposition in the chapter that deals with systems of equations. Basically, we end up with a system of equations that we need to solve in order to end up with our constants. So let's see, we want a plus b to equal to 2, and we want a minus 4b to add up to 1. Okay, so now what I'm going to do is I'm going to subtract the bottom equation from the top one, and I end up with b minus minus 4b, which is 5b, equals 2 minus 1 here. So 5b is equal to 1, and this gives me b equals 1. Okay, over 5, excuse me. And now I'm going to plug this answer in to the first of the equations. So a plus b equals 2, so a plus 1/5 equals 2, so a is equal to 2 minus 1/5. So A is equal to 10/5 minus 1/5, which is 9/5. Okay, so what are these A and B again? Well, apparently what we have just found is the following. If we start out with the fraction 2x plus 1 over x plus 1 times x minus 4, then we can actually rewrite this as the sum of the two fractions. And let me just make sure I plug in A and B for the right part. So we said A was the numerator of the x minus 4 part of the fraction. So we get 9/5 over x minus 4 plus 1/5 over x plus 1. Okay, so we have found two numbers, A and B, such that the original fraction 2x plus 1 over x plus 1 times x minus 4 is actually equal to the sum of the two fractions 9/5 over x minus 4 plus 1/5 over x plus 1. Now normally we don't need to check our answers, but this should work out. So let's take 9/5 over x minus 4 and add to it 1/5 over x plus 1. Now if I make common denominator, the common denominator is just the product of x minus 4 times x plus 1. So far so good. I'm going to multiply the first fraction through top and bottom through by x plus 1. So we get 9/5 times x plus 1 plus, then we multiplied, in order to get here, we multiplied the second fraction through by x minus 4. We end up with 9/5 x plus 9/5 plus 1/5 x minus 4/5. And this is divided by x minus 4 times x plus 1. So again, here I am checking my answer, just in case you were wondering what on earth am I doing. Okay, so I'm checking that the sum of these fractions actually ends up equaling 2x plus 1 over x minus 4 times x plus 1. So I'm going to collect like terms, and I end up with 10 over 5x, and I get this by adding 9/5 x and 1/5 x, and then plus 9/5 minus 4/5 is gonna be 5/5. The denominator remains x minus 4 times x plus 1. We end up with 2x plus 1 divided by x minus 4 times x plus 1. So that's it. I have just checked my answer, and it is true that 9/5 over x minus 4 plus 1/5 over x plus 1 is indeed 2x plus 1 over x minus 4 times x plus 1. So pretty much partial fraction decomposition is the opposite or the reverse process of adding two fractions. We end up rewriting a single fraction as the sum of two or more fractions that actually are simpler. And believe me, this is going to come in handy when you do calculus.